Welcome to the Ducks Unlimited podcast, the only podcast about all things waterfowl. From hunting insights to science-based discussions about ducks, geese, and issues affecting waterfowl and wetlands conservation in North America, we bring the resource to you. The DU Podcast with your host, Dr. Mike Brazier.
Hey everyone, thanks again for joining us for another episode of the podcast here. You know, when we launched this podcast a few weeks back, it didn't take very long for me personally to get excited about what we were pulling together here because, being in a scientist role, I quickly realized that it was going to give us an opportunity to bring to our listeners, our members and supporters, some topics that you otherwise would not be exposed to, but that I think, and I think you all will as well, find them very interesting, very unique topics, things that you may otherwise not hear about in any other location. And today is one of those days. This is one of those podcasts where we're going to be talking about something that a lot of folks probably aren't aware of, and I certainly wasn't aware of. And it relates to something that that most everyone is familiar with in some way, and that is fleas. But we're not going to be talking about fleas and your canine companion. We're going to be talking about fleas and their intersection with waterfowl, in particular snow geese and Ross's geese. And it's a pretty interesting topic. It was a fairly recent discovery. And to help us in this conversation, we're going to welcome in probably the person that's going to know more about this than anyone else in North America. I hope I'm not overstating that. But we're welcoming in Dr. Vanessa Harriman, conservation scientist with Ducks Unlimited Canada's Institute for Wetlands and Waterfowl Research. Vanessa, welcome to the show.
Well, thank you, Mike, very much for that introduction. I'm really excited to be talking about this interesting topic today, fleas and geese. So
to get started here, tell us a little bit about your personal background, your professional background and interest, and what it is that you currently do for the Institute.
So I currently work in Manitoba, but I actually was born and raised in Northern California. And I was raised in California in an area with not a lot of hunting opportunity. With that said, I did have the chance to go out mostly upland game, bird hunting, and waterfowl hunting throughout my childhood and youth with my dad and my younger brother. But not having a lot of hunting opportunity around us in Northern California, what that meant is that we were often kind of woken up at 3 a.m. and shoved in the truck for a long drive to be able to go hunting. So, which was really exciting and really fun adventure as a kid, but not as fun when you became a teenager. So my interest in conservation really started with hunting, and like many hunters, my dad is an avid conservationist, and so we've been long-term supporters of Ducks Unlimited and California Waterfowl Association, and so that's really how I got interested in conservation. I did eventually make my way up to Humboldt State University, and when I went to Humboldt, initially I thought, well, I'm going to be a marine biologist, which I think a lot of Californians have these grand plans of becoming marine biologists. And
I wanted to be a marine biologist whenever I grew up, whenever I was younger. I was in Mississippi, and I wanted to be a marine biologist. Nowhere near the ocean. I was in North Mississippi.
Yeah, and I think that it's so appealing, but there are obviously limited job opportunities. And so while at Humboldt, I was quickly exposed to the wildlife program there and was immediately hooked. And so I entered into the wildlife program, and they really encouraged us as students to take summer internships and get experience really early on in our career. So after my second year of university, while my fellow students were kind of dispersing throughout the states and going to these nice, warm, tropical climates, I was just absolutely obsessed with getting an internship in the Arctic. I wanted to go to the Arctic. And so I think it was naive being from California, thinking like, oh, I would like to try this, but I was warned that it was going to be cold and there were going to be mosquitoes the size of helicopters, but that did not dissuade me. And I applied for a position with Dr. Ray Alasoskis. Ray and his team had a variety of projects going on at the Carrick Lake Research Station. And the Carrick Lake Research Station is located way up in northern Canada in the territory of Nunavut. And the research ranged from Arctic fox work to sea duck work, but really the primary focus was on the lesser snow and Ross's goose population ecology.
Yeah, we had, I think you probably know this, we had Ray on for a couple of episodes talking about that. And so yeah, the listeners can go back to those episodes and find out a little bit more about the location of some of those colonies and sort of the context of that. But you are an example of one of the many students that Ray and his colleagues have helped guide and train, and you have helped collect some of the data that now feeds so much of what we understand about snow goose. So I just want to interrupt you there and make some of the connections between you and your work, and then one of our previous guests on the show. So you were there with Ray up at Carrick Lake. So carry on.
Absolutely, and he has really provided a tremendous opportunity for many, many students like myself. And once I had experienced Carrick Lake, I knew that's where I wanted to go do my master's research. And so after a brief stint back down in the prairies with Delta Waterfowl, I then returned to Carrick Lake to conduct my research for my master's project, which we're going to talk a bit more about in this podcast. And I was actually based out of the University of Saskatchewan there. And that is where I met my PhD supervisor, Dr. Bob Clark, and also Dr. Russ Dawson at the University of Northern British Columbia. And so for my PhD work, I didn't work on waterfowl, but rather on aerial insectivores. And specifically, I worked on tree swallows. And aerial insectivores are a group of birds experiencing population declines throughout North America, and the objective of that work was to identify factors influencing offspring quality and survival. And although it's not waterfowl, there's a really strong wetland connection with that work as well, as wetlands are vital for aerial insectivores like tree swallows, because they produce the insects that the birds feed on.
Right. Yeah, I think we had talked about that a little bit earlier. That's a topic that I think would be really interesting for our listeners, and so sometime in the future we may have you back to talk about that. A lot of times we don't think about the connections that the wetland conservation work that we do, how it benefits other groups of wildlife, and so that PhD work was a perfect example of that. So we'll have to get you back on.
Thank you. That would be great. I'd love to talk about tree swallows. So as you mentioned, I'm now a conservation scientist here with the Institute for Wetland and Waterfowl Research, and I'm also working with the National Boreal Program. And the main focus of my work here is to understand factors that affect wetland-associated bird populations in the Canadian prairies and also in the boreal forest. And specifically, the research I've been involved in recently focuses on understanding how human activities affect these populations. And really the goal is to use this information to help us adapt conservation delivery programs. So really, in essence, to use our scientific knowledge to maximize the conservation benefits.
Yeah, and we had a recent episode with Dr. Fritz Reed talking about the boreal forest and some of the work that Ducks Unlimited and Ducks Unlimited Canada does there. And so the work that you're doing now, the role that you're in, is strongly in support of the work that Fritz spoke about. And that's one of the things that we hope to accomplish. One of the many things we hope to accomplish through this podcast is to introduce people to the great scientists, the great biologists and conservationists that work for our Ducks Unlimited organization. organizations and to sort of pull these, to tie these different people and initiatives and efforts together and help people develop a complete picture of what we all do as a collection of organizations in support of waterfowl and wetlands. And so you're in one of those positions that provides that strong support for some of our programs way up north. I think we'll get into the topic at hand. We've referenced it a couple of times already, and it's this curious case of fleas and geese. And so, in my best attempt, maybe it's a lousy attempt at a joke, I'll say, let's jump right in. So you've probably never heard that one before, right?
Never. Actually, I haven't.
Oh, really? Wow. Well, leave it to me to come up with a corny joke here for us.
Thanks, Mike.
So, as I understand things here, this is an observation that was made in the early 90s. Now, I'm gonna hand this off to you to take us through this. But the presence of fleas, these little tiny ectoparasites, the same type of fleas, maybe not the same species, not the same taxonomically as you find on dogs and cats, but the same family of fleas nonetheless were found in goose nest up in one of these colonies, Carrick Lake, up in the Queen Maud Gulf Bird Sanctuary, and so that phenomenon started raising various questions. And so pretty soon you came along and you were the graduate student to investigate this. And my understanding is there's sort of three components to this, and maybe you can take us through each of these and I'll jump in and we'll ask some questions. But the first was just to sort of characterize the flea, what it was. And then ultimately, long-term, what we want to do is kind of figure out the interaction of this flea with the geese, right? And so there were a couple of steps involved in that. One was you just had to sort of document how abundant it was in the nest or on the hen, or I'm going to let you describe all those details. And then the other was to sort of figure out, well, what effect did it have on the goose productivity at all? So is that way of looking at it, those three components, is that sort of the way you approach the issue?
Yeah, so I think of it probably in two components mostly, which is what factors influence the number of fleas in nests. And to answer that question, we had to understand whether we could use blood coverage on eggs as an index. And then the second is, did fleas affect goose nest success? And then looking at both individual and population level effects. Okay,
so take us back to when this was first observed. Let's just kind of give folks some context of what was observed and what it appeared like in the nest, and let's just go from there. Can we do that?
As you mentioned, they first documented blood on goose eggs in 1991. And so what they had observed were these little dots of blood on goose eggs. And we actually had to look through old journal entries to find that kind of first documentation of blood on goose eggs. But it wasn't actually until 1997 that they realized that the blood on the goose eggs may be attributed to flea infestation. So it was at that time that they actually documented fleas in association with these blood-covered eggs. And as far as we know, this had never been documented before, although we do know that this phenomenon does exist. I think really what the difference was here is that by 1997, they noticed that in some nests, almost an entire egg's surface would be covered with blood in some of these nests. And so much so that actually down was stuck to this dried blood. And so you'd pick up an egg and the eggs actually have like a smell. I don't know how to explain it, but the blood-covered eggs have a smell. It's not a pleasant smell, but yeah, it is like iron. But I think, and maybe I say it's not pleasant because I also associate it with high flea infestations. So and sometimes you would have feathers stuck to these eggs in really highly infested nests. So that was this phenomenon that was described.
Yeah, and just to clarify, the phenomenon of fleas in birds or bird nest was not totally new. Like I know from reading some of your articles that previously fleas had been documented and had been most commonly studied in like passerines, in altricial birds, those birds that are featherless at birth and that can't fly, right? Or that can't are not independent at birth, right?
Absolutely, and that's true. So there's about 2,500 species of fleas, and about 6% of those species infest birds and bird nests. But most of the research that has been conducted on fleas has been conducted in these kind of songbird nests. And this is probably because when you think of a flea in a nest, you think that it might have the greatest effect on the chicks that are stuck to that nest all the time. They can't move. They can't leave that nest. And so you may think that the impact would be the greatest on this vulnerable little naked chick. And so, to our knowledge, this is one of the first studies of the impacts of fleas, or it is the first study, of the impacts of fleas on a species like waterfowl, where their offspring are highly developed when they hatch and leave the nest quickly. So really, we think the impacts of the fleas would actually be on the female attending the nest or on the eggs themselves.
Yeah, because the ducklings or the goslings, I think most of the folks listening to this will probably know this, but within approximately 24 hours of those ducklings or goslings hatching, they're out of the nest. And so they're precocial. They have little fluff balls, right? They're just little covered with down, and they're off and out of the nest within about 24 or so hours. So big difference there from our songbirds that stay in the nest for a couple of weeks. So, okay. So we had this discovery of fleas in the nest, and we needed to figure out what was going on. And I will say that when I was preparing for this, I had to teach myself a little bit about fleas, and so I got on Wikipedia and started looking a little bit and other sites, and I fleas. I've had some exposure to fleas. I think most of us have through our dogs or cats or whatever else. And man, they are just, I know you'll probably cringe at this, but they're somewhat hideous creatures because they carry they're vectors for so many different diseases. I had no idea. So anyway, you probably bristle at me calling them hideous creatures. You probably developed somewhat of a...
I developed respect for them, but I can't say that I like them. They are absolutely hideous. And I think that kind of one of the interesting things with this species of flea, which was named Ceratophilus vagabundus, is that it's actually a larger flea than what you would kind of see on your dog or cat. And so they're fairly large fleas. And
do they? I know in my reading I learned that fleas are oftentimes host specific. Of course, that never stops the flea that gets on our dog from biting us. But but in this case, would the fleas that on these geese, would they bite you as humans?
Yes. So they would. But most of us didn't react. So early in the season, when you would be visiting the old nest bowls that had melted out, or late in the season after all the geese had hatched, all the eggs had hatched and the geese had left the colony, and you would go near these nests, you would have sometimes hundreds and hundreds of fleas jumping on you.
Be the first to know when ducks are on the move. Sign up for DU's waterfowl migration email alerts and receive ongoing in-depth updates on the latest habitat conditions, weather changes, and hunting reports for your flyway. Visit ducks.org/migration alerts.
Relative to the normal dog flea, how big are they? Are they 2 times as big, 3 times the size? Or are we talking larger, more monsters?
They're not like the helicopter mosquitoes in the Arctic, but I guess everything is bigger. So I would say 2 times bigger, maybe.
Okay, so definitely noticeable.
They're bigger.
Visible, highly visible.
They're
okay.
noticeable. They're highly visible. And so you're standing next to this nest bowl and maybe counting the membranes and egg caps to determine whether or not that nest had hatched or not. And the next thing you know, you're covered in fleas. Like your legs are just covered in these big jumping fleas. And to my knowledge, most people didn't react to these flea bites. But we did have one PhD student, I felt very, very bad for him, who would react just terribly to these fleas and have massive welts. And I mostly feel bad because I introduced the fleas into our cabin, into our main cabin. So when I was experimenting with how to kill these fleas in order to count them without them jumping away, one of the methods I tried was actually putting acetone or nail polish remover on cotton balls and putting those cotton balls in a bag with the nest or with the dead goose. And sure enough, you would see these apparently lifeless fleas inside this bag with this goose, and you would open it up and start counting fleas, but then the next thing you know, they'd start twitching and jumping around. So they actually recovered from the acetone. And so I would on occasion introduce fleas into our cabin, and this poor fellow graduate student reacted incredibly poorly to them.
You know, I can't help but find myself wondering, whenever you signed up for the graduate program under Ray, did you know did he tell you that you were going to be counting fleas? Or was this sort of like, oh, yeah, come, I have a project. We'll be working on Snow and Ross's geese up in the Arctic. And then after you got there, he shared with you, oh, yeah, by the way, you're going to be counting fleas? Were you fully informed when you went into this that you were going to be working on fleas?
I was fully informed, and I probably actually asked to be the one to study the fleas on the geese, if I remember correctly. So Ray and Dana Kellett had started monitoring the blood on the eggs a few years before I first volunteered at Carrick Lake. So they had the intention of starting a monitoring program and then to investigate the effect of fleas and or blood on reproductive success of geese. And so once I went up there, I actually went up to Carrick Lake thinking I was mostly going to work with Arctic foxes. I had this grand plan of working with these cute furry creatures. And then the next thing I knew, I was absolutely hooked by this incredibly interesting phenomenon. And more so, I really wanted to understand whether or not these fleas may impact the goose population. So I also became very, very interested in population dynamics, which is ultimately what both my master's and PhD work was on. So I didn't know I was going to work on fleas. I just find it. And I found some way to actually continue my parasite work, ectoparasite work, in my PhD or for my PhD as well. So I asked some similar questions with tree swallows. Yes. I just couldn't let it go. So I do.
So you were a glutton for punishment in that regard. Okay. Very cool.
I think they're so fascinating.
Yeah. Well, they are fascinating. Okay. Where were we here? I think, to me, when I was reading through the publications here that came from this work, one of the parts that was interesting to me was just the basic need to relate I guess just to document that the amount of blood on the goose eggs was an index of the degree of flea infestation. Of course, I guess what you were really looking for is a way to quickly index the degree of infestation. And looking at a group of eggs and estimating the percentage of those eggs or the amount of the egg area that's covered with blood is far faster than having to go through each nest and count all the fleas, right?
Absolutely.
But you first had to document that. You first had to document that relationship between blood coverage and flea abundance, right?
Yes, because that's really what was unique about this phenomenon, is that researchers and folks up in the Queen Maud Gulf at Carrick Lake were documenting or observing this blood coverage on eggs, and that was really unique. And it's challenging to collect entire nests and painstaking to go through all of that nest material to find all of the fleas. So it took anywhere between 1 and 10 hours to process any single nest. And in some of these nests, the nest material and down is very matted with blood, and you have to pull apart all of those kind of bloody feathers and try to search for these, although larger than your dog flea, still small black fleas. And then on top of that, there are thousands of flea larvae in these nests as well. And so initially we thought we would probably count flea larvae as well, but that just became an impossible task, really, because they are so small and so numerous. And so what we did was we had to collect some nests, and we also collected some adults, some females associated with those nests. And we processed those nests and counted every adult flea in the nest and adult fleas on the female, and determined that there was a strong relationship between the proportion of the eggs covered by blood and the number of fleas in the nest.
In the nest. And one of the things that I want to just touch on here is one of the findings was there were very few fleas on the birds themselves. And just to make sure people understand what happened, when you say you collected the birds, these birds were killed under a certain number of birds were killed under a scientific collection permit. The Canadian Wildlife Service issued the permit, and you actually collected the birds, and then you would, I don't know if you shaved the feathers off or what, but you had to physically go through every part of the bird looking for these fleas. And so I'm guessing they're dark. Obviously, if they would stand out against the feathers of the goose. Is that right? Yes.
So we actually went through the feathers. So very systematically searched through the feathers and took all of the fleas off the goose. And as I noted, we had to kill the fleas first.
Yeah. And how did you end up doing that? And tell us what you ultimately discovered.
Ultimately, what we ended up doing was freezing the nest material and goose twice. So you would freeze it, thaw. So fleas can survive a single freeze, but they cannot survive a freeze-thaw cycle. So that is what would kill them. And so once the fleas were dead, we would systematically search through the adults, and we only found at the most four adult fleas actually on any given female.
Wow. And so how do you explain that? I mean, because the fleas, the blood on the eggs is, tell us what that is. That's, where does the blood come from? Does it come off of the female, or does it come from the flea?
Right. So the flea life cycle, what we determined from this research was that the flea was living in the goose nest, and that's very typical for fleas of rodents and fleas of birds, is they actually spend the majority of the time in the nest, and that they only go onto the host to feed and then drop back into the nest to lay their eggs. And so what we think that the blood was from is actually the fleas defecating or pooping out undigested blood to feed their larvae. So larvae of fleas actually feed on blood and some other organic material in the nest.
Yeah, and that's the same process that occurs with dog fleas, right? All the black stuff that you see in your dog bed or on the floor or wherever, especially if it's a white blanket, that's all dried blood that's been defecated out, right?
Yes, exactly. And so that's what those larvae then eat. And so you'll have that black kind of defecated frass is what they call it, and that'll be everywhere inside the nest bowl. And that was also likely what was being deposited all over these goose eggs in nests with high flea intensities.
I think what we want to do here is we'll wrap up this episode. We've encountered a few more topics than what I envisioned, so we're gonna be able to get 2 episodes out of this conversation, which is a good thing. I find it very interesting, and I know there's a lot more to discuss. We haven't even talked about what you found with respect to how the degree of flea infestation influenced productivity, which that's really the key conservation and management message here. So I want to make sure we give due time to that. So I think we'll wrap this episode up and have you back on, Vanessa, if that's okay with you, and we'll go from there. Does that sound all right?
Absolutely. It sounds great. Thanks, Mike.
Okay. Well, thanks for joining us, Vanessa. We'll have you back on the next episode.
Thank you.
Special thanks to our special guest today, Dr. Vanessa Harriman with Ducks Unlimited Canada's Institute for Wetlands and Waterfowl Research. We also thank Clay Baird, our producer, who does a great job getting these podcasts edited and out to you, our listeners. And to you, our listeners, we extend also special thanks for your time, for your passion, and for your commitment for wetlands and waterfowl conservation.
Thank you for listening to this episode of the DU Podcast. Be sure to rate, review, and subscribe to the show, and visit www.ducks.org/DU Podcast for resources based on today's topics, as well as access to more episodes. Opinions expressed by guests do not necessarily reflect those of Ducks Unlimited. Until next time, stay tuned to the Ducks.